to do. All right, so let's take a look at our our parallel circuit one. So what remains constant in a parallel circuit?
Voltage.
Voltage. So then we know that my voltage across my capacitor is going to be equal to what? 18 volts RMS. And my voltage across my resistor is going to be what?
18 volts.
18 volts RMS. Okay? And what's another name for our what's another name for our what's another name for our parallel circuit?
Current
divider.
Current dividers. Okay? So what's going to happen is that our current is going to be divided up against the other two. And again, it's just, we're going to always have to use tricks. So if we want to calculate out what our total current this time is that we're going to have to do the trig function to come up with what our total current is. All right, so again, then we want to, and we know that as I add in more resistance into a parallel circuit, it becomes more conductive, right? So what we have to do is we have to convert everything into conductance also. So what our first step is that we're going to go ahead and we're going to convert everything into conductance first. So we're going to take our X of C and we're going to calculate our, what we call it in now for capacitive reactance. Opposite of capacitive reactance is our subsuctance. And that's just basically to calculate that out. It's just 1 over our X of C. And that'll calculate out what our BC is. So that's our first step that we have to do. See how conductive is our capacitive reactance at. So what do I get for subsuctance? I'll give everyone 5 extra points if they can say that word. It's been about 8 years now. I still can't say that damn word. Yeah. It is on page. If you want to know what the word is that I'm trying to say, it's on page 458. Capacitive substance. Yeah, substance. Yeah, it's on page 458. Yeah.
Oh, wow.
Yeah.
Everyone gets 5 extra points.
Yeah. All right. So what do we get for, like I like to say, BC? A lot easier. That's why I only say that word once and then that's it. We're done.
The whole crap word.
Yeah. All right. So what do we get for BC?
166.7 micro. Yeah.
Oh, say it one more time.
166.7.
166.7. 166.7 microsiemens. Yeah, the opposite of resistance. All right, so there we got our BC, and then we got to do the same thing. Then we need to find our conductance of our resistor, and that's just the 1 over R. So what do we get for that?
222.2 micro.
220.2 micro Siemens. Right? Is that what you said?
222.2. Just take out the 0.2 there.
222.2. There we go. 2222. All right. All right. So then so now once we know those, again, since we like to practice using our trig, we will. So what we want to do is we want to find our total conductance of our circuit. We want to know how conductive our circuit is. So now, what we're going to do is, now we're going to take a look. You can see that my BC is going to be at my plus Y and my G, my conductance, is going to be at my plus X. So we know that my angle is going to have to be what? Positive or negative? We're going to be up in the positive angle. Okay? So what we're going to do is we're going to find what our total conductance of this circuit is. So what you're going to do is just put in your 222.2 microsiemens, hit your second XY, put in 166.7 microsiemens, hit your second, and go rectangular to polar, and then we should be able to find our total conductance and our angle at the same time. So it should be a very small number. Is this thing going to be more conductive or more resistive or more? Let's see, what do I want to say? More conductance or more susceptance? More conductance. Susceptance. I'll never get there.
Looks like that.
All right. So what do we get for y? Did we come up with a number yet?
36.87 degrees.
Okay. So you got an angle of 36.87 degrees. Positive. Okay. And then for your y.
Backwards.
277.8 microsiemens. All right, good. All right. All right, so now what I would do on this next step, since we know that it's a current divider, we're going to want to divide up our current across our capacitor and our resistor. So what we want to do is find out what is our total current of this circuit. So what would be my total current then? So to figure out my total current, I know that I have to have my total current is equal to I over VR, right? So what I'm going to have to do is I'm going to have to convert my Y into my impedance. And all I'm going to do that is I'm just going to take 1 over Y. I'm just going to do the inverse of that. And I'm going to get my Z, my impedance of the circuit. So what do I get for impedance of the circuit?
Oh, 3.600.
3.6 kilo.
Okay, 3.6 kiloohms.
What was your formula for that?
Yeah.
It's just 1 over Y.
Inverse. Oh.
Yep, just do the inverse. Hit your inverse key. You should have a key that has 1 over X or X minus 1 or something, I think it is. Certain calculators. Yep, so just do the inverse of it. All right. So then once you get your impedance, then we can figure out what our total current is by just taking V over R, or Z in this particular case. So what do I get for total current?
5 milliamps.
5 milliamps. Okay, so now we got our total current. Now what we want to do, so we get to practice our calculators, is that what we want to do is find out what our current is once for our capacitor and our current of our resistor. So we can do that with our polar to rectangular function. This time we're going to do it with our current. So we're going to put in our current to 5 milliamps, hit our second XY, put in our angle, a positive angle, and then we're going to hit our second, second from polar to rectangular function, the one above your multiplication sign if you have the 30x. Okay, and then we'll figure out what the current is going across the capacitor and the resistor. So we're doing it the same way. The only difference is that we're just doing it with current instead of voltage this time. Go ahead and say a number. Or what? For micro, for which one? R or C?
You got 4 million.
4 million? And then if you got 4 million for which one? The resistor or the capacitor?
Whatever came up first.
Okay, which is the first one? First one is always X, right? So which one is on our X? So our conductance is on our X now, right? So that would be related to our resistor. So the first one is going to be our resistor. So your first answer is going to be your, you got 4 milliamps RMS. Is that what everyone else got? Everyone agree with that?
Yep.
You say it's so correct.
So, yep, so using your polar to rectangular function.
What do you use?
What's that?
What do you put in?
Oh yeah, so you're going to put in, so what you're going to do is you're going to put in your 5 milliamps,
Okay.
then you're going to hit your second XY key.
Okay.
Then you're going to put in your angle, 36.87. Then you're going to go and, did you get that far? And then you're going to hit your second XY, or your second, not your XY, but your second, and then go to polar to rectangular function. The first answer is always going to be your X value. So that's this line here, so that's going to be your conductance or your resistor here. So that'll be going in there. No, we're just working on current right now. Not PR. Okay, and then what do you get for IC then? If you just hit your second XY, then you're going to get your second one, which is going to be your capacitance. The current of your capacitor. So what do you get for that current?
3 millirms.
3 milliamps. Okay? So then our angle then is going to have, so this one's going to be our 4 milliamps. This will be at our 3 milliamps, so our angle is going to be,
Is that milliamps RMS or just?
yep, milliamps RMS, yep. Yep, and that's our angle. Our angle is going to be right here, and that's going to be our 36.87 degrees. Okay? The total current is going to be our 5 milliamps. Okay? So it's the same way that we're doing it like we did on the other one. The only difference this time it's going to be based on our current. Okay, so then we can just use, we can just calculate out using Ohm's law then to figure out our powers. So what do we get for our power total? So what do we get for total power? 90 millibars, yep. Volt amps reactance. unit stays the same. So power going across my capacitor or my resistor, whichever one you calculated out. Or we can go ahead and take our total, so once we figure out our total power, we can go ahead and use our polar to rectangular function, take our total power and divide it up against those two also. Either way works, or just using Ohm's law, either one.
54 milliwatt.
What'd you get?
54
For VA. No VAs, good. Yeah, and then the power across our resistor.
72. 72 or
720 milliwatts.
720 milliwatts.
720 milliwatts?
Yeah.
720 milliwatts. Okay?
I got numbers on there.
I got 72.
I got 72.
That's what I would think too. I would think that would be, because the other one was only 54, 72. We know that they have to, we know that we're pretty close to getting pretty close to 45 degrees, so we know that those two would have to be equal. Okay? So at 45 degrees then, our two currents going across each branch then would be equal. At 45 degrees. So, all right, how did that one go? Getting to be a little easier?
Do one more.
One more? All
I
right.
hate this class.
All right. Any questions on this one before we move on to the next one? All right, so let's find a good one here then.
A good one in our eyes, not yours, please.
All right, we gotta have a little challenge here.
No.
All right, Tyler wants a hard one.
It's the hardest one you can find, and we don't have to do it later.
There we go. All right, here's a good one right here.
24.
All right, so do this one within the class here, and then we'll put up the answers there.
What's the?
See if you can
what-
kind of do it without my steps.
1024. 24. Yeah.
Yeah, 1024. Now while you're doing that, then I'll set up my net. Yeah, so you get stuck, ask the guy next to you.